a notes off the center table. And your homework, I actually typed up here incorrectly. The 15, 5 through 7 assignment does encompass the rest of the homework. So if you've already done that, sweet. I'm not teaching you anything new today. We're just reviewing your skills, making sure we know the difference between the sampling methods, and we're seeing which would be best in each situation. So one thing you guys may not know about me yet is back in, well, actually I think most of you do know this. Back in college, I worked at the radio station. And that's where I got my DJ name of DJ Hudcap. So you don't choose your DJ name. It was a rule at WOBN. Your DJ name was bestowed upon you as opposed to chosen by you. Yeah, my friends picked it, right? So I was a car guy, am a car guy. So that's where, like, Hubcap, the thing on your tire, but they thought Hudcap was funny. My friends don't have a great sense of humor. So, we are at the radio station, and we want to do, an appreciation event for the radio staff. So, one manager asks workers, what special food items should we add to the cafeteria? We want to do something nice, we want to add something in. And they both decide to systematically sample their employees. So, one overwhelmingly gets answers of salad bar. Another employee overwhelmingly got answers of omelet bar. How could this have happened? They both systematically sampled. So when we systematically sample, we're trying to eliminate bias. Right? We're not choosing the people, really. It's like they sample every fifth. So go ahead and highlight, just so we remind ourselves. Systematic uses that interval. That's why they do every fifth. So what do we think? What could have been the issue here? Okay, didn't maybe see what everybody else thought. Izzy, what are you thinking?
Well, maybe they started with different people.
Okay, that could have happened. Kylie?
There was a pattern in the data of the people they sampled.
Yeah, there could be, and that creates issues in systematic, but a pattern in food taste would be really, like, everybody lined up based on their food taste. Like, that would be really tough to make happen. Andrew, what do you think?
Maybe it's just a coincidence.
I mean, yeah, sometimes those things just happen. We could run another sample, see if we can make that coincidence disappear.
Maybe there had like an omelet in your hand. Like, what do you want to do? This should be added.
What would steer your food preference? Casey, what were you thinking?
Like what time of day that you're doing that?
Does it tell you when they systematically sampled?
No.
So, easy way to systematically sample, we talked about stand at the front door, right? What if the owner is there at 4 in the morning when the radio turns on? And some radio stations never turn off. Like in Coshocton, our radio station tuned out at 11 o'clock at night, literally went to static. Columbus, most of your radios stay on, but nobody's there. So people start showing up in the morning to actively DJ, like, the trip to work. So if the owner surveys all the people getting there at 4, 5, 6 in the morning, well, yeah, of course they want omelets. And then the manager shows up at 10 a.m. and he starts surveying people 10, 11 o'clock, noon, 1 o'clock. So the big issue here probably was time of the sample. We don't know when he did that. But what we do know is they got very biased results. So what could we do to try to get rid of this bias? Or what could be a solution here? That hand went down. Is he? Ooh, ask him on the way out. Grace?
Ask them like the same time of day, like they both ask at the same time.
Okay. Andrew?
Maybe get a variety of results over, like, every hour.
Ooh, variety, like, yeah, so that would be systematic and be like a long-term systematic type sampling.
Yeah.
Justin?
Never mind. I just read the question over.
Okay. Kate?
Maybe like after they eat.
Ooh, after they eat. That's interesting. Whether you did a survey about food before they ate or after they ate. I've got 2 samples here, right? Could I put them together and make one big sample? So another way that I could try to fix the bias is if I merge the 2 samples samples and then compare quantitatively. Now, if overwhelmingly we got salad bar, but we asked a dozen people, and overwhelmingly we got omelet bar, and we only asked 3 people, yeah, these samples could be different sizes. So if you merge the 2 samples, that could help get rid of bias as well. Alright, so really what we're talking about today is how to get the best samples possible for the questions that we're trying to ask. So let's think about this situation. Who watches American Idol, The Voice, any of those things? Yeah. So, anyone ever vote? You vote on those shows?
Sometimes.
Yeah?
Yeah.
Who do you vote for? Or who did you vote for?
Well, I voted. I didn't really pay attention to what episodes, so I literally just voted for the team I liked. So
Okay.
I just,
How'd you vote?
I went on there's like a website app thing.
Okay.
And you just click on it.
Did you only vote once?
Yeah, I've only done it once. Because the other times it's like I don't really watch it a lot, but I watched it and I vote.
Okay. Anyone else vote on those things?
Oh yeah,
Justin?
there's like
You
SNL.
voted? Who'd you vote for?
Some bearded dude.
Some bearded dude.
Oh,
How'd
yeah.
you vote?
I picked his beard.
Well, how did you vote? Like, what method? Did you call in? Did you text in?
Texted him
Did you vote once or more than that?
like 3 times.
Why'd you vote 3 times?
I like the bearded dude.
So, are your 3 votes equal to that 1 vote?
No.
So, what could we say about your voice comparatively?
It's bigger than hers.
Your voice is now stronger because Justin put in 3 votes. But you're both only one person. You're both only one opinion. And yet, you got more of a say.
I count as 3 though.
You do count as 3. So, when they come out on the stage, and they're like, all right, ladies and gentlemen, Ryan Seacrest or Nick Cannon or whoever it is, the singer who the country has declared the best singer. Is that really true?
No, there could be
Who did the declaring here?
The people vote counters.
Ooh, the what?
Vote counters.
Well, not the vote counters. So, the people who voted, what else did those people who voted have to have done if they voted, probably?
more than one.
Watch the show. So, really, country, cross that out. The people who declared this, come on back. So, if you want to write it in your own words, I'll write it up here in just a second. But it's the people who watched the show and voted, and every vote isn't fair. Because Justin decided he liked that bearded guy 3 times as much as Julia liked whoever she voted for.
Guess what? He won.
He won?
Yeah.
He won because of your 3 votes. Right there. So, people who watched and voted, and that could have been multiple. And this is actually a term. Have you guys ever heard of something being weighted?
Mhm.
So, like, some teachers weight grades, and some certain things are weighted different ways. So, when you vote multiple times, that gives you weighted opinions. Now, Justin's opinion is weighted 3 times as heavy as Julia's opinion. Because Julia voted once, Justin voted 3 times. Now, on most of those, because sadly I do watch those occasionally, they're on TV and I'm not paying attention, it just plays. Anyone ever listen how many times you're allowed to vote?
As many as you want.
It's not as many as you want.
Yeah, it was
It's
like
not just 1 per number. Well, depending on the show, I don't watch them all, so there might be some that's just 1. At the end of the show, at least for American Idol and The Voice, I think. Julie, do you know?
I did it for Dancing with the Stars, and it
Okay.
was like you had like I think it was 8 was the most you could.
And that's per method.
Yeah, because you could do like you could split it up evenly and like give everyone a vote, or you could do like all your 8 votes.
So American Idol, back when I cared about it, you could vote 10 times per method. I could text in 10 times. I could online do 10 votes. And I could by phone call in 10 votes. I could vote 30 times for 1 person.
Multiple phones though. Just get your
And then you could get multiple phones or multiple computer logins. So these weighted opinions really make this very invalid. This is totally invalid. So that winner, yay for them, they're a good singer, but they're not the country's choice. They're the people who watched and voted, and especially those multiple votes. Abby, question? What's up, Abby? Or do you have a comment?
Yeah, my sister did it. It was like some lip sync battle thing. There was like one night where they went live and you could like vote on it.
Yeah.
It was like the microphone.
So, I forget what toothpaste company it is. You guys don't even know what I'm about to say.
Yeah.
So they have a commercial. They have 5 dentists sitting in a room, and they're asking the dentist, "Would you suggest whatever toothpaste for your clients, your customers?" And they go down the line. They're like, "Yes, yes, yes." And a squirrel runs in the window, runs across the floor, up this guy's pants. And the last guy, no! Which then you're like, oh, well, he said no because the squirrel. But so that's them spinning their data. They're telling you real data. They're telling you real results. 4 out of 5 dentists said yes. Now, there was no squirrel involved when they took the sample, but they're trying to spin that to make you forget about the dentist who said no and make you think about a squirrel involved. But really, if we think about that, who said no? What if we changed that commercial and said this many dentists said no? What would we say? CJ, what do you think? How many dentists, if we spin it instead of said yes, we look at the said no? I mean, they said 4 out of 5 said yes. So that then means 1 out of 5 said no. So does that actually mean that only 1 dentist said no? Why? Who can talk about this? Flint?
There's like more than one dentist in the world. Like there's only like there's only like 5 dentists in the world. No, there's like millions and like.
But so why then are they saying 4 out of 5?
Because that's how many they surveyed.
Not even necessarily. Do you think they really only asked 5 people? Because if I go and ask 5 people and 1 says no, do you think I'm going to be happy with 1 out of 5 saying no? That's not really actually good. That's 20%, right? So that 4 out of 5, and I mean we could write it as 4 out of 5. What would that be? What type of fraction that has been? Did you ever hear? I can't. Hands keep going up and then down. Abby?
Isn't it like an estimated?
No, not estimated. That is real data, Kylie. That has been simplified or reduced.
So it's like the average.
Not the average. They could have. So let's think about this. That 4 out of 5 could actually mean 8 out of 10. It could actually mean 80 out of 100. If we want, it could actually mean 400 out of 500. It could actually mean 800 out of 1,000. I can keep going. What is it that we don't know here? Okay. I mean, they either said yes or they said no, right? So brand X, Colgate Crest, whoever you think. Xavier?
Actual amount of dentists they serve.
So we don't know the real values.
Would it be like invalid?
So we don't really know how many dentists. What's a different way we could communicate this data that doesn't use like 4 out of 5 or 8 out of 10? Because that's making you feel like, well, they only asked 5 dentists or they only asked 10 dentists. But that's not true. We don't know that. How else could we communicate this data, Casey?
Like 80%.
Ooh. So we could instead use 80%, but they don't like that. Because what does your brain immediately think about, CJ? Well, not only that, but the fraction makes you think only one said no. What does this make you think about said no? So instead of thinking about one said no, then you'd be thinking 20% said no. And in your head, that's a bigger deal. That's more important than one individual dentist. But that's them spinning the data and tricking you into not focusing on what you really should be. And guys, if 20% of people are saying no to you, that's a pretty big percentage. So like when you look at Listerine commercials, 99, this is really funny, they've actually spun their commercials. 99.9% of germs, right? So that not 100%. But they're not talking about people, they're talking about germs, so percentages, right? But now they've spun their commercials. Anyone seen a recent Listerine commercial and look at the percent they talk about? They say 100.
But that might not be true.
I can't play audio right now. If we get to the end of class, I'll show you some of these commercials I'm talking about. They then now reference 100% of people. They decided to ask their users, are you likely to, and the survey they did is like ridiculous. They're like, are you likely to fight a grizzly bear? Or are you likely to, so what they did was they called it the survey of bold. And they literally said that people that use Listerine are bold. They're ready to go be bold. 100% of them are going to go be bold. That doesn't matter. I don't give a crap what the other guy using Listerine is doing. I want to know how effective that product is. They're communicating data that doesn't matter. But yet, you're watching the commercial, and you got Listerine stuck in your head now.
People buying Listerine.
Yep. Yeah, seriously. That's what they would do. They would hang out in a Listerine aisle and wait for somebody to grab Listerine. Excuse me, sir. Would you fight a grizzly bear? I'll try to play it at the end of class. Abby?
So wouldn't that be, fake? Because you're not actually asking,
Yeah, the question is irrelevant.
Exactly. People just like it. It's not like they know anything about oral.
Alright, so I often say that if I didn't work in a school, if I wasn't a teacher, I'd probably work out in the woods somewhere. Love being in the woods. So let's say you've decided to become a wildlife researcher. Come back and tell me, I will be jealous of you. And you go to a lake and you catch 50 fish. So go ahead, highlight this. We catch and tag 50 fish. So there are now 50 fish wearing these tags, these trackers. And don't worry, we tag the fish where they can't feel it. They don't mind. I'm serious.
It's in their
They can't feel it. They don't have nerves there. Not really. Depends. They get used to it. So, how many fish are in the lake? We don't know, right? It's a lake full of fish. We don't know. We can use math to predict. We go back a week later, right? We know we caught and tagged 50 fish. So this is the older data. So what we did, so this is the past, right? We caught and tagged 50 fish. We don't know the population of the fish. So we caught and tagged 50 out of, we don't know. We go back a week later and we catch another 50. However, we're not tagging those fish. We're checking, do they have a tag? And when I pull them up and I count them and I get to the end of the day, I found out that 15 of them were tagged. Hayden, what do I do with this information? So there's 35 fish still out there swimming around that had tags on them that I didn't catch. So we know there's more than 50 fish in the pond, right? I caught 35 that didn't have tags. But so I had related tagged fish over all of them. And this is population data. How many tagged in the population? How many total in the population? Justin, what could I do with this?
Wouldn't you add the 50 fish that weren't tagged to the 50 fish that were tagged? Because
So there are only 50 fish with tags, period. We're not adding more tags.
yeah, but they caught the 15 that were tagged.
So let me try to back this up and see if I can get your conceptual understanding a little bit better.
Next week.
What if when I went back to the pond and I caught 50 more fish, what if 45 of those fish had my tags on them? What would you say about how many fish there are probably in the pond total? Do you think there'd be a ton of fish or not that many fish? Not that many. What if I went and caught 50 fish and only 5 of them had tags? There's probably a lot of fish in the pond, right? You're making those inferences using your basic math skills. You just don't realize it. You're saying that the amount of fish tagged compared to all of them will vary directly to the next time I do that. Very directly means proportional. So please jot down off to the side here. This is direct variation. And you will need to know this word probably for the state test when it comes around. Direct variation, all that means is proportional.
Oh yeah, did you tell us that we were talking about?
Yep, we've talked about this before. So the amount that you had tagged on all the fish will be proportional to what you caught today. Hayden, so what do I do? Why would I do that? But I'm looking at tagged. I only know. Do you know how many fish in the pond don't have tags?
No.
Then don't use that data. You know how many fish in the pond have tags, right? That's our 50. So we need to talk about fish with tags. Today, when we caught our fish, how many fish had tags? 15. How many fish did we catch in total today? 50. These 50s are two different things. That's 50 tagged from the last time we were here, and this is 50 total from today when we're here. So, we can, to solve this, cross multiply so we get 15p equals 2,500. Cross multiplying, you set those equal, so the 15 times the p, and the 50 times the 50, because 50 times 50 gets 2,500. Then to get the p by itself, anybody, divide by the 15.
Wait, so the P is 52?
No, we don't know what p is. We do now, though. Once I do 2,500 divided by 15, what'd you get, Jack? 160. Now, does that have a decimal after it? It rounds up then. So we could anticipate, we would predict there are 167 fish in total. This data is how they tell you whether or not you can take the fish home with you. If there are enough fish in the pond that there's like a big population, sure, take the fish home, eat it, you're good. If there's not enough fish in the pond, it's catch and release, you gotta put it back so the population can keep getting larger. Yeah.
Wouldn't the population be 166?
But it's 0.6, and numerically when we're working with these, we just follow the rounding rules. Now, when you're working with like cases and things where you have to purchase, you have limited money or limited supplies, then we sometimes just have to round down regardless of the decimal. But here we're going to follow the decimal rule. And Andrew, I would take either answer. I would take 166 or 167. Yeah. Exactly what I just said. So that they can collect data, predict how many fish there are in total in the lake, and determine whether people can keep the fish, like to eat them, or whether people have to put them back, because if there's not enough fish, I'm not going to let you take fish out of the pond that already doesn't have enough fish. That makes sense? And it's just population control, so that we don't deplete all the fish. Because we eat all the fish, and there's no more fish to make more fish, we're screwed. Right? Like, flip to the back. Check this one out on your own. It is just like the fish problem. So I want to see if you can set this up on your own. You caught and tagged 100. That was the then. You came back. And you fly over, count 64 marked deer out of 1,200. You're not catching, you're just counting. And a lot of times they'll use cameras mounted on the planes to do this. So the cameras will be able to use heat sensors, and the heat sensor will pick up where are their deer. And then it will track, because there's normally an RFID chip on the tag. RFID is really cheap now these days. So they can scan, and they scanned and found there were only 64 marked deer out of 1,200 that we saw today. We want to predict how many deer are there total in this reservation. So take a moment, try to set this up. I'm going to jot a couple things down, but you should be trying this on your own. Well, it depends, because it depends if we really want to do it through foundations or do it through class. Because it depends on our settings. And we can probably just have tools and everything. Yeah. There's not much more in that. Well, either shoot me the date or I'll get it from you at some point. I just want to put it on my calendar. Mr. Price, when we flew over today, what data did we collect? 64 out of 1,200. So what do I do with that? Yeah, I set this equal to my past data. Now, there is the proportion method where to figure out P, if I can figure out what happens here, then I can figure out my P, but that does not work easy here. So cross multiply.
Yay!
So 1,200, I'm going to write all the work out here, times 100 is equal to 64 times P. This is 120,000 equal to 64P. We then, Justin, do what?
Divide 120,000 by 64.
Get rid of that 64. Very good. And Dinah.
Wrong language.
I don't know Italian. What is our p-value here?
1,875.
Another way that we could look at this, if you really like percent method, in our sample today, we caught 64% of all the tagged deer. So our sample amount that we got today is 64% of the total amount of deer. So this 1,200 over 1,875, that would be 64%. Because my group is 64% of, like, we caught 64 out of the 100, so that 1,200 out of something, that would also be proportional. So what I'm saying is you could also set this up as we caught 64 out of 100 total, that was the same as 1,200 out of, and then this denominator would have to be 1875. That's another proportion. Total population. That's all the deer in the park or the reservation, whatever we're talking about. So they would use that data to determine, can you tag keep your deer? Read this. We can probably get through this quickly, so read this for a moment. Reagan, what's up?
So when you want to agree with assistant manager too,
Why?
it's a convenience sample, so they could have gone to the banana aisle and just asked people in there.
If I'm really lazy and I'm asking a question about bananas and I want to be convenient, well, what if I do this at the bananas? B-A-N-A-N-A-S? I forget who that was, but thank you to her for me always knowing how to spell bananas. So if we did that at the bananas, that means that this is going to be biased. So assistant manager 2 realizes that assistant manager 1 must not like her job, and she takes a systematic sample, which regardless of where you are, that would be more fair. And it says the entire store. So where could you take a systematic sample of all the people in the store?
In the store.
Entrance or the exit? Yeah, so like, if I want to ask people, hey, did you buy bananas today? Just do your systematic at the exit. And then you're going to get a fair, unbiased result. So one last little question to discuss this, and then I'll pull up a couple of those misleading commercials. What about simple random? So this guy, you guys know what like Kroger Plus cards are and stuff, right? Like your membership card. So this guy goes through the membership data, randomly chooses 50 people to call, and he gets the result: 30 out of 50 people are buying bananas. Where does simple random fall in like the realm of bias, in the realm of like how much we can trust it? Julia?
Well, he picked them randomly, but it was still the people that have the cards who couldn't know that they go there.
Okay, but will going there a lot affect if they buy bananas or not? No. And notice 30 out of 50, a little over half. 15 out of 30, half. Their results are very close. Systematic and simple random should produce similar results. You got a couple more people here, a little bit higher percentage, but you're still really close. So any questions on our sampling methods to wrap us up? When we use each, when each is the best. So we got like 8 minutes left. I will try to pull up a couple of these commercials. Will somebody over on that side turn on my amp, please? Big button by the post-it.